I'm going to talk about interpolation. There's also interpolation in IRR when in financial management when we're talking about internal rate of return. But I'm going to discuss the interpolation that we need to do when we're calculating the value of an option, right? Okay. So we need to use the normal distribution table, and the normal distribution table is a 2 decimal table, right? That we have on the other side. But see, when we do our calculations, most of the times we get 4 decimals, but we need to have the exact value of that answer, right? So what we need to do, let's just go direct to a question on the calculation of the value of the option, so that we see how do we go about the interpolation. So we have this question. It says, let me just minimize. It says a binary option pays off 240 Rand if a stock price is greater than 50 Rand in 6 months. The current price is 45 Rand and its volatility is 25%. The risk free is 7% and the expected return on the stock is 11%. Calculate the value of the option. The question we are not much interested in. What we need is to find the value of minus 0.4864 using the tables. But the tables are not enough. We need to go further to interpolate. So we're going to use 3 methods basically. The one which are going to do the interpolation manually, which is below here. Of course, we can also use Excel. We can also just use the internet to calculate the value. Okay, so we have this question and our formula here. I'm sure you see it's ln of S subscript O divided by X plus R, which is our risk-free, minus sigma squared divided by 2 multiplied by the time all over our sigma multiplied by the square root of time. We insert our values here. That is ln of 45 over 50 plus 0.07 minus 0.25 squared divided by 2 multiplied by 0.5 because time is 6 months. Right, so it's 6 divided by 12, then all over 0.25 multiplied by the square root of time, which is 0.5. Then we are going to get, if we can press this at once, or we can calculate in parts, maybe this part, and this part. Then we add the numerator, then we divide with the denominator. So we're going to get minus 0.4864, right? And then that minus 0.8464 is the one that we need now to interpolate, right? So that we get its exact value. Why are we doing this thing called interpolation? Might need to explain that. Okay. Okay, so you see, if our answer here was going to be 0.4, then there was no need to interpolate. We're just going direct to the tables and look for 0.4. If we're looking for 0.4, we just come to our tables here and we look for minus 0.4. It's minus 0.4, right? We go to a table with negative. So the negative is here on top, minus 8. But some tables, they'll give you a negative, minus 0. 0.0 minus 0.1 minus 0.2. If there are positive below, there's a table of positive values, right? So if we go on top here and our answer was minus 0.4 here, we're just going to draw a line. We start from this side and we get this one, and there's also 0.0. So if we add 0.4 plus 0.0, we get 0.4. So we draw another line here. So that was going to be our answer. Let's assume we've got minus 0.7. Minus 0.72. If it was minus 0.72, we come to minus 0.7. We draw a straight line. If you want to proceed with it out to the end, that's fine with us. Then we draw a line here. That was our answer. right? To make it much clearer, I've presented it in a Word document. To make it much clearer, minus 0.72, I can choose to draw my straight, to highlight this straight line, right? And I come this side, I highlight this, right? Maybe to highlight it in a much clearer way. If I do this, okay, I come to our tables, I would highlight here. Let me highlight this, right? Then I come, so here, minus 0.7, I have minus 0.7. Now I need plus 0.02. I come to 0.02. If I come here, see, draw if I want to proceed with it. That's me. Then this one, I highlight it. Let me put a color that is similar to this. Okay. So where the two intersect here, minus 0.72 and 0.02, which add up to minus 0.72, that's where our value is. So this becomes our answer. If I want to make it clear, maybe we'll do this. This becomes our answer like that. So that's how we interpolate. But now we also have a situation when we have minus 0.72 to 3. How are we going to get it? But what we are sure of is that minus 0.7223 is in between minus 0.7 and minus 0.73. I'm sure you agree, right? So because we can have 4 decimals, we will need to interpolate. So let's try to interpolate minus 4.864. I just finishing deleted, then we interpolate this one. So now when we're interpolating a 4 decimal like that one, we just need to understand this. We got our answer is here is minus 0.4864. So to interpolate, we need to have the value of minus 0.48. Because minus 0.48, I'm sure you see here that we can get it minus 0.48. If we come here, I draw up to the end, then 0.8 here, I can highlight and get it. So I need the value of minus 0.48. So we are going to say the value of n of minus 0.4864 is equal to, I'm writing below here, n of minus 0.48, right? So I will look for the value of minus 0.48 minus here, minus 0.64. So this 0.64 is this part, take note of that. And this part, you are taking it as it is. You are just saying 0.64. You ignore the first 2 decimals, 4 and 8, right? Then you just take it as 0.64. If it was minus 0.5842, you are going to say n of minus 0.58, then minus 0.42. I'm sure you can see what I'm trying to explain, right? So on this one, we took n of minus 0.48 minus 0.64, the last 2 decimals, then multiplied by n of minus 0.48. So here we're just repeating the 0.48, which is here, right? Which is here. Then minus n of minus 0.49, right? So what we are trying to establish is that, okay, this minus 0.48, we have it, but we want to find the exact value of this decimals, the remainder. Why? Because basically you can realize that the value that we are looking for is in between, let me delete here, is in between, the value that we are looking for is in between minus 0.48 and minus 0.49. That's where our value is, because we have minus 0.4864. So to repeat quickly, we are saying, to get our answer, we are saying that is equal to n of minus 0.48, which is this part, right, minus 0. The last two decimals, 0.64, multiplied by, let me delete this bracket that I've put, multiplied by n of minus 0.48, which is just the repetition, minus, now we're finding the difference between the two, right, minus n of minus 0.49, right? So these are the values that we have from the answer. Now we need to find the exact values from the table. So what we will now do is to say that's equal to n of minus 0.48. What is n of minus 0.48 from our table? Let me undo what we did here so that it becomes clear. N of minus 0.48, I can draw my straight line on minus 0.4. Here, I get, let me put a green here, right? Then I go to the column that have 8 here to make it minus 0.48. That's the one here. Right, let me just put in another different color with the same color that we put previously, right? So the value of minus 0.48 is this one. Right, that's 0.31561, but most of the tables, they were 4 decimals, so we are going to work with 4 decimals. So that's 0.156, we round to 4 decimals, minus 0.64 multiplied by n of minus 0.48. n of minus 0.48, we already have it. It's 0.3156. Then minus n of 0.49. n of minus 0.49. We already have 0.4 here. 9, we come and look for 9. We draw, we highlight the column for 9, maybe up below. Let's do it. Right. You see? Then where they intersect, they're intersecting here. They're intersecting here. So this is the value of, this becomes the value of minus 0.49. Right? I've put it like that. That's 0.3121, because it's 0.31207 rounded to 4 decimals. Right? Now to get the final answer, I'm just taking my 0.3156, then minus 0.64, then we calculate the difference between 0.3156 minus 0.3121, right? I'm getting 0.0035 like that. And then I come here, I have 0.3156 minus, we multiply 0.64 and 0.035, right? Then from there I'm going to get 0.00224. Then I subtract 0.3156, 0.3156 minus 0.00224. Then I'm going to get 0.31336 to the 2 decimals. The 4 decimals, I mean, that's 0.313. Here we said our answer is, let me just correct. I think I wrote something I was saying something, but I wrote something. If we subtract here, you are getting 0.31336. So to 4 decimals, we can get it as 0.313. All right, it's okay. That rounding off, I think it's just a rounding off. It's just a rounding of error, nothing much. So that's what we are getting, right? And we get our answer. This is the same thing that we did here. So that's how we do interpolation. I think it's somehow clear. Then the other way of doing interpolation is to use Excel. Let's try to interpolate using Excel. Let me open a new way book. So you see the value that we have here is minus 0.4864. So you can just come and say that's equal to norms remember it's norms this. When you click here, it should just give you a z in the brackets. Then you put your answer inside that z, which is minus 486.4. You close your bracket, you get your answer. That's 0.31334. So it's just the same with the answer that we got, right? I said 3 methods. The last method is to go on the internet and you say norms dist calculator, norms dist calculator. Here, norms dist calculator. Then you come here, you see we are having our open space here. I just come and say minus 0.4864 like that. Then I say that's equal to, it's giving my answers 0.31334 like that. So that's how we do interpolation. So that's all for today, guys. Thank you.